Welcome DKP Sogong aboard. Your learning journey starts now. Ever thought a proof is just one file, one verdict? Think again. It's way more complex, a living thing with stages. We're cracking open that mystery today. So, what's the deal with proofs? They have a life cycle. Think of it like a food chain. You generate it, verify it, then it needs to be digested by the community. The real kicker, a proof isn't just born once. It has two births, first inside its own system achieving native closure. Then, the public birth, can others rebuild it from scratch without needing the original author's magic touch? That's proof metabolism. It's not just about if it exists, but if it can be reborn, reused, understood. This loop, this dance between internal closure and public inheritance, that's where the action is. Forget just checking boxes. We need to track if it can actually be reconstructed across different forms. Okay, so we know proofs are dynamic. But here's the snag. The current setup is clunky. Three big bottlenecks are slowing us down. First, zip monoliths. Great for distribution, terrible for digging into specific pots. You can't easily cite a single line or reuse a lemma. Second, open bridge debt. Saying a bridge to classical math is open is fine, but without IDs, owners, or records of failures, it's just empty words. Third, failed reverse reconstruction. Many systems run, but if you hand someone a tiny clue, can they rebuild the whole thing? Often no. The fix? Stop hiding behind the archive. Expose a clear searchable tree structure alongside the zip. Make it citable, diffable, teachable. That's how we unlock the potential. So how do we tackle this mess? Enter DPMCS, the Duan proof metabolism and canonicalization system. It's not just theory, it's got tools. Python kernels, JSON schemas for tracking proof status, dashboards, even integrity ledgers using SHA-256. We've already run a pilot on the twin prime TBCOHC problem, showing a 4-layer reconstruction process. Importantly, DPMCS doesn't just give you a truth verdict. It produces executable objects that capture the proof's journey and state, making them reusable, understandable, and ready for the next generation of researchers. It's about building infrastructure for proof digestion, not just generation. Why should you care? Because this isn't just about AI churning out proofs. It's about ensuring those proofs become part of the collective knowledge, not just isolated artifacts. DPMCS uses 10-dimensional vectors to track a proof status far beyond simple true or false, the future. More open bridges, better friction maps showing where understanding breaks down, and systems designed for easy reuse. The big takeaway: proofs aren't static documents. They're processes, living things that need nurturing through their entire life cycle. That's the shift we need.